Bismillah ar-Rahman ar-Rahim. My dear students of Ajman University College of Pharmacy and Health Sciences, second year course Pharmaceutical Dosage Forms 1. And this is the second topic that is, as you see in the screen, which is capsules. Okay, as we already talked about previously, in the beginning of each topic, first we will list the learning outcomes for that topic. So by the end of this topic, you should be able to differentiate between two types of capsules. These are hard gelatin capsules and soft gelatin capsules. So there are two types, and with the time, as we go or as we progress in this topic, you will find out so many differences between the two types of capsules. But of course, there are some similarities between the two. The other thing you need to know about is to list the advantages and disadvantages of gelatin capsules, whether hard or soft. The third outcome is that you should tell us about the composition of the shell capsule. Okay, capsule is made from the outer envelope, that is the shell, and the filled materials inside the capsule. So you need to know both. What are the composition of the capsule shells, plus what are the ingredients commonly encapsulated inside these capsules. Another thing is you need to tell us about compendial requirements. Yani here I'm talking about the quality control tests for capsules. And one of these quality control tests is referred to as weight variation test. And we have another test which is about content uniformity. Now you need to differentiate between the two types of these two tests that are commonly applied to capsules. Another important thing with regard to capsule is the storage condition. At what environment do you store it? You will find out later that storage condition is very, very important in case of capsules because they are very sensitive to the environmental condition. But after talking about the learning outcomes, let's start as usual with the definition. Remember the definition of powders and granules. First, we want to describe how the capsule looks like. With powder, we said that these are solid dosage forms that is composed of finely divided particles intended for internal use or external use. Now here we are talking about unit solid dosage form. Again, we are describing it as solid dosage form, but here we are adding the term unit, and unit indicates here that each capsule is forming a unit or forming a dose, one dose of the medication. So we are talking like tablets, for example. Can you say tablets they are considered as unit solid dosage forms? Yes, we can say the same with tablets because each tablet is considered as a unit and it contains one dose of the drug. طيب, فإذا the definition is unit solid dosage form in which now in this unit solid dosage form you have the drug plus usually other ingredients which are encapsulated or contained within, yani they are filled inside either hard gelatin capsules or soft gelatin capsules. Isn't unit solid dosage forms in which the drug and other ingredients are contained within a hard or soft gelatin capsule shells. Now these capsules can be filled commonly, okay, this is a common thing, can be filled with powder ingredients, and that is in the case especially for hard gelatin capsules, or it can be liquid or semi solid in case I'm talking about soft gelatin capsule. Then here we can say the following. Commonly, the soft gelatin capsules will encapsulate liquid and semi-solid preparations. But what about the hard gelatin capsule? Normally or commonly, it will encapsulate powder ingredients or granulated ingredients. Now, if we want to be more accurate or to describe the composition of the filled materials inside the capsule, then you should know that hard gelatin capsules can actually encapsulate almost any type of materials provided في condition في هناك شرط provided that these materials do not dissolve or interact with the shell. You will see here in this figure, you will see capsule, which is hard gelatin capsules. If you look carefully, you will see the top part, which is referred to as cap, and the bottom part, which is referred to as body. Then hard gelatin capsules are two-piece capsules made of cap and body. Later we will talk about this, but you will see that it can be encapsulated with powder or granule formulation. It can be also capsulated with paste, يعني semi-solid. It can be encapsulated with another smaller capsule. It can be encapsulated with a small tablet. So I can put small tablet inside the hard gelatin capsules. Even liquid, you can do that, but provided that you can prove that this liquid that you encapsulate, number one, does not interact with the shell. Number two, it doesn't leak, because if there is a liquid, it can leak from the spaces between the cap and the body. فإذا I can almost encapsulate hard gelatin capsules with any material. Now this is very similar even with soft gelatin capsules, even though, let's go back, the usual case is that powder materials are encapsulated in hard gelatin capsules and semi-solid and liquid are encapsulated in soft gelatin capsule. If we need to use other materials, then we need special equipment for that, and that is one reason why we don't see capsules like hard gelatin capsules with semi-solid encapsulated inside, or another capsule inside, or another tablet inside. We need a special machine, or we need to do it manually, so we will not do it in industrial scale. طيب, as I said, whatever you encapsulate should not dissolve the gelatin, which is the main ingredient in the shell composition. لما احكي shell, شو المقصود في الشell? What do you mean by shell? It's the outer film or the outer layer that makes the capsule shape. Okay? Capsules are important because capsules make 20% of prescribed drugs. يعني if we want to do analysis of the prescriptions, we will find that 20% of prescribed medications are in the form of capsules. معناته, is it important to study about capsules? Yes, it is. How did we classify capsules? We classified them to hard gelatin capsules and soft gelatin capsules. Now we will talk mainly about hard gelatin capsules, and later on we will start talking about soft gelatin capsules. But if you remember, we said that hard gelatin capsules are also referred to as two-piece capsules. Okay? Now, soft gelatin capsules are not two-piece capsules. So this is a difference. يعني في عندنا هون two pieces. حكينا what are these two pieces. خلينا نطلع عليهم. Let's look at them. Okay, you see here For example, look at this capsule. You have a longer body. Okay, this is the body of the capsule. This is where you fill your ingredients. And there is the cap. Now, the cap is shorter, right? Plus, the cap has a larger diameter than the diameter of the body. That's why the cap will slide over the body. Okay, so let's go back and look at the figure here. We have the body, which is longer, and snugly or tightly fitting cap sliding over the body. فإذا which one has larger diameter? It's the cap. And this difference in diameter is very important, as you will see later in the filling of capsules. Okay? طيب. Another thing is many capsules that are contained inside a bottle. Sometimes you buy capsules and these capsules are inside the bottle. This is the case especially for soft gelatin capsules, because for hard gelatin capsules they will be mainly packaged in a strip packaging or blister packaging. But for soft gelatin capsules you may find it in a bottle container. So in the bottle containers they usually use a desiccant material. Okay, you see here you have desiccant material. What is desiccant material? Desiccant material is a material that is capable of absorbing moisture from the surrounding environment. Not only moisture, sometimes even the gases. Okay, like for example smell, or like CO2, etc. It can absorb, it can take these things from the surrounding environment. Earlier I told you that capsules, gelatin capsules, are very sensitive to moisture. That's why you need to store it in a specific condition. Now, the environment should not be high in humidity, and as well it should not be low in humidity. There should be an optimum humidity surrounding the capsule shells. That's why when you put the capsules in a bottle container, sometimes you will see also a desiccant material in a sachet is provided inside the bottle. يعني بيكونوا حاطين, so they will add, the manufacturer will add a desiccant material that is within a sachet, and they will put this sachet inside the bottle containing the capsule. شو الجوب تاعها? What is the job of that? Is to absorb moisture from the surrounding environment. Example of this desiccant material which you need to memorize: we have the dried silica gel, we have clay, we have phosphorus pentoxide. Phosphorus pentoxide is very powerful, and we have activated charcoal. The main or the most commonly used desiccant material is the dried silica gel, and I want to show you these silica beads. I will do a search for you to see the silica beads. Okay, so these are the silica beads. As you see, they are blue in color, and they are in many cases available in sachets. When they are added, as you see here, silica gel, they are added inside the bottles. Sometimes even when you buy bags or you buy jackets, you will see these silica gel sachets inside them. and that is to absorb smell, absorb moisture from the environment. Okay, so what is the job of desiccant material? The job is to protect against the moisture in the atmosphere. How do they protect? By absorbing the moisture from the atmosphere. Now we want to talk about the advantages of pharmaceutical dosage form when we are talking about capsules. First, remember when we talked about the disadvantages of powders, and we said that it is difficult to mask the taste of powder. We said that, right? Now, in capsules, it is an excellent way to hide or to mask the taste of the drug by hiding it inside the capsule shells. But what about the taste of the shell? Does it have a taste? Well, normally it has a very faint taste. Its taste is not clear, or it's not, you cannot really tell, oh, this is a taste of capsules. So it doesn't have a distinct taste. Okay, so this is an advantage when you compare it to powders. Second thing, usually when you fill the capsules, unlike tablets, when you compare it to tablets, okay, tablets are compressed to a great extent. بينما, on the other hand, what you fill the capsules with, usually in uncompressed form. فبالتالي, therefore, capsules, once the shell dissolves, the shell of the capsule dissolves, again, let's go here, when this shell dissolves in the stomach, and this can happen very quickly, I have carried out an experiment whereby I studied the time it takes for the shell to dissolve, and I found that within less than 6 minutes, all of the contents inside the capsule shell will dissolve. فبالتالي, once the material inside is exposed, okay, because it's in the uncompressed form, it will dissolve very quickly compared to tablet preparations. Okay. Of course, the second advantage, as I said, where we have uncompressed drug which is inside the capsule. So once the capsule shells dissolve, the material inside, because they are in the incompressed or uncompressed form, they will dissolve faster if you compare it to tablets. Tablets, as I said before, it's compressed to a hard extent, and therefore its breakup will take more time if you compare it to the uncompressed form of the capsules or capsule filled materials. Another good thing about capsules, they offer, or they can be used for variety of administration routes, including, of course, in addition to oral, we have inhalation, we have rectal, or the content of the capsule may be diluted with, for example, water and applied in the vaginal area, rectal area, or maybe used topically or orally after dissolving the content or suspending the content of the capsule in water. Now I will show you two devices. We have the spinhaler device, which is a dry powder inhaler, and the rotahaler. Both of these two devices, اللي هم DPIs, use capsules, okay, to encapsulate the dose of the drug. So I will show you this. Going back here, I will type spinhaler. Now this is the spinhaler. You see this photo, okay? You see a capsule, and this capsule is fitted inside the spinhaler. We'll see this one. See, you see here there is like a fan, and you fit the capsule in this area of the spinhaler, okay? Also we have the rotahaler. This is a diagram of the rotahaler along with spinhaler, both together, and both of them, as I said, they use capsule in the formulation. Let's see it. Okay, you see the device here. This is the rotahaler, and this is the capsule. Also, this is the spinhaler, which I already showed you before. Okay, in the spinhaler. Okay, this is the capsule. So what I mean to say that you can use capsule for the purpose of administering it in different routes. Another important thing is that they are easier to swallow compared to tablets. Now there are two reasons for this. One is that gelatin, which is the main constituent of the shell, can slip easily through the throat, so it can be swallowed easier than tablet. Number two, the shape of the capsule. Okay, the shape of the capsule, as you have seen, is like oblong. Now that's one reason why you will see some tablets that are referred to as cablets, زي البنادول. Okay, cablets, cap means it comes from capsule, so let's يعني tablets, يعني the other part of tablets, so it's like combining the shape of the capsule but in the form of tablets. So this is cablets. I will show you how. What you see here is cablet. What you see here is cablets. Okay, see here in this photo you see tablet and you see also capsule. Now this tablet, because it's in similar shape to the tablet, in similar shape to capsules, it's referred to as cablet. Now this shape makes it easier to swallow through the throat, okay, from the mouth through the esophagus and then into the stomach. It's because of the shape, okay. Another advantage is that you can alter the release rate of the drug. Yani, for example, I have capsule preparation and I don't want the content of the capsule to dissolve in the stomach. I want the release to be in the intestine. In this case, what I can do, I can alter the release site of the drug. Instead of the stomach, now it will be in the intestine. How? I can coat the capsule shells. I can coat it with what we call enteric, okay, coating. This enteric coating around the capsule shells will protect the capsule shells from the stomach juices, and it will only allow the shell to dissolve in the intestine. So when the capsule is swallowed in the stomach, the shells will remain intact, nothing will happen to them, even though you have gastric juices there and they are supposed to dissolve very quickly. But because of enteric coating, the coat will protect the capsule from dissolving, but once it gets to the intestine, it will dissolve readily, and that is because the enteric coating is sensitive to pH. Enteric coating at low pH, yani acidic pH, it will not dissolve, it will remain intact, okay. But when the pH goes above 5 or 5.5, the coat will dissolve readily. So what I mean to say, we can control the drug release rate and also we can control the site of release. Another thing is that capsule shells can offer protection of the drug. Yani some drugs, maybe they are sensitive to light, to oxidation, to humidity. It can be protected inside the capsule shells. But I have to be careful here, and I have to be honest with you. If the capsules are stored in humid environment, the shell itself will deteriorate. Yani this protection, let's say, is not complete because the shell is very sensitive to atmospheric condition, which includes heat and humidity. And even oxidation, there is no full protection against oxidation because air can still get slowly inside the capsules. So the protection here is not complete, okay? Another good thing about capsules that they are suitable for encapsulating drugs in clinical studies. Now, what does that mean? Okay, clinical studies means studies that are done on human. For example, let's say I want to test two medication, or let's say a medication with a placebo. Now I am coming with new terms. Yani, I have a new drug that I want to prove to the people and to the FDA that my drug is safe and effective. So what do I do? Let's say you have a company and you have come up with a new drug. Okay, and this drug is effective in animals, in vitro, it's effective. So you took permission to do the testing on human and to prove that it is safe and effective. So what do? In order to do that, you need to recruit individuals in this study, human individuals, okay, and to give them the medication and to see whether this medication is effective or not. Now the problem is you need to have a control group. شو يعني control group? The FDA says that if you want to approve the medication, you cannot just test the drug. You need to test it in comparison to a placebo. Placebo يعني شو يعني placebo? Who knows? It's similar to, looks like a medication, but it's void of drug. يعني ما فيهاش الدرug. It looks like the medication but without drug. طيب, how can I do that? Okay, because I don't want the patients to know whether they are taking the drug or the placebo. يعني imagine that I'm talking about a drug for pain. Okay, let's take an example of a drug for pain. If my drug is in the form of tablet, okay, and I want to test this tablet, okay, now I want to give it to the recruited individual and see whether it's effective for relieving pain. Now I have to compare it with placebo. Placebo should look exactly similar to the medication. طيب, how do I prepare the placebo? I have to prepare similar tablet, right? طيب, but there is a possibility that the individual will know that this is a placebo or it's the drug. So in this case, what do? The easiest or the best way is to put the medication inside capsule, hidden inside the capsule, and the placebo hidden inside the capsule, and then find out if there is a difference in relieving the pain. I'm sure that if I tell you that I'm giving you a placebo for pain, and then the next day I tell you, okay, what happened to your pain? You will tell me, no, the pain is still there, even it's more now. But if I'm telling you, well, you are taking something, it can be a drug or it might not be a drug, then you will tell me, what you really feel regarding pain. So the reason why they put the drug in capsules is to hide the drugs so that people will not recognize if they are taking a medication or a placebo. So I'm comparing capsule formulation with another capsule formulation. One contains drug, the other one does not contain drug. When I want to do this clinical study, I will recruit individuals. I put them in two groups. One group will be having placebo, the other one will be having the real medication, and then I will compare what is the effect of placebo and medication on pain. Another good thing about capsules is that it happens frequently or commonly that in many cases in the hospital you will be required to prepare a liquid preparation from capsules or sometimes even tablets. So you'll prepare a liquid preparation, and in order to do that you will need to empty the capsule in a liquid or crush the tablet and then mix it or add it to a liquid preparation. You can also add it to food or drink. This is especially the case in case of children who are unable to swallow. So if someone is unable to swallow capsule or tablets, I have the option to put it with food or put it in a drink. Now, disadvantage of a hard gelatin capsule that it is easily tampered with. شو يعني easily tampered with? If we go back to the capsules and look at it, it contains two pieces, so it is possible that people can remove the cap and maybe replace the contents. فمعناته you can tamper with, you can play with it, and this is something negative about the capsules, although there are ways to prevent this. Okay, yani we have techniques that can prevent tampering with capsules. The other disadvantage which I told you about, it's affected very quickly and easily with humidity in the environment. So if there is high humidity, what happens to the capsule shell? They will absorb moisture from the environment. When you have moisture from environment, the capsule will become sticky. Okay, they will stick with each other. They will become sticky when you handle them. Not only that, but also microbial contamination will grow in these capsules. If in the case you have low humidity, now this is also not good, because capsule shells will lose moisture from the shells. بصيروا shells not elastic, not flexible, they will be fragile, يعني they can break easily in low humidity. Another thing or another disadvantage اللي هي some people, even though شوف انتبهوا لهاي disadvantage, although it's easy to swallow, especially when you compare it to tablet, but because it's a solid dosage form, it's maybe difficult to swallow by some people, زي مثلا في children, and that's why we use liquid preparation for them. Another disadvantage اللي هي it's more expensive if we want to compare it, for example, with making tablets. Why capsule preparations are more expensive? Now, one reason is because capsules are not made in the same company that will fill the capsule with the formulations. Yani let's take Gilfar for example. Gilfar has many products in the form of capsule, but the capsule shells are not manufactured in Gilfar. It's bought from another company. فمعناته this is expensive because it is not the same company that makes everything. So they will buy hard gelatin capsules from another company, and then they will fill the formulation in Gilfar. Okay, so Gilfar will only prepare the formulation. Okay, so far we talked about, or we described the hard gelatin capsules as two-piece capsules. We defined capsules as unit solid dosage form. We talked about the advantages and disadvantages of hard gelatin capsules. Now we want to talk about the manufacture of capsule shells. Remember, just a while ago I told you that the capsule shells are made in a specialized company that is specialized in making capsule shells. These companies, they do not fill formulation, they just produce the shells. Then company like Gelfar, Neopharma, Medpharma, etc., these companies will import the shells to their site, and then they will fill the capsule shells with the formulation. So the question here is, how do they make the hard gelatin capsule shells? How do they make them? Well, the empty shells, let's see what they are made of. The main material of hard gelatin capsule is gelatin, and gelatin makes about 80% of the shell weight. يعني the majority of the shell comes from ايش? From gelatin. Now in some cases they may add sugar. Sugar can give desirable taste to the shell. It can also give some flexibility to the shell. But this is not always. يعني maybe in few cases they will add sugar. Usually it is gelatin. In addition to gelatin, they use water. And water in the shell accounts for 13 to 16% W by W, يعني weight by weight. 13 to 16% W by W, that's a lot of water. But this amount of water is very critical. It should not be less than that, and it should not be more than that. It's very critical. What is the importance of water in the capsule shell? It gives the shell the flexibility, elasticity and flexibility to tolerate mechanical stress. Mechanical stress comes from the machine that fills the capsules. It comes from handling the capsules. So it's very important that the capsules are flexible. But what happens if the water content is less than 13, let's say 10 or 9? بصير عندنا ايش الشell؟ حكينا fragile. Let's go to the disadvantage here. In low humidity you have fragile. لأنه الshell is losing water, so it becomes fragile. It will lose the flexibility. What happens if it is more than 16%? It will become sticky and microbial contamination will start to grow on the shells. طيب 13 to 16, why microbial contamination does not grow? The reason is the water in the shell is all bound to the gelatin, يعني occupied. يعني الwater, there is no free water, there is no extra water. All of the water is being used to give the mechanical flexibility of the shell. فبالتالي there is no more water for bacteria to grow. طيب, so gelatin and water, they are main composition. What other things that can be added? Well, there are other ingredients that are not compulsory. They are additional ingredients, and these includes color. So I can add color to the capsule shells. So the capsule shells can be colored. The color that you are allowed to use, the colors that you are allowed to use should belong to the groups F, D, and C or D and C. These are the permitted color, the safe colors that you can add to the capsule shells. What do you mean by F, D, and C? It means food, drug, and cosmetic. يعني ال FDA, طبعا لما احكي ال FDA usually I'm talking about United States Food and Drug Administration. ال FDA classified colors to different groups. I have the F, D, and C اللي هي food, drug, and cosmetics. يعني it can be added to food, drug, and cosmetics, or a color that can be added only to drug and cosmetics. Okay? These colors are allowed to be used with the capsule shells. Another agent which is important also to talk about here اللي هو titanium dioxide. Titanium dioxide. Now this agent is used also in the capsule shell composition as optional to provide the shell or to make the shell opaquant. Okay, to make it opaque. Opaque means not transparent, or it does not allow the light to pass through the shells. An opaque means doesn't allow the light to pass. Okay, طبعا this is good when you don't want the light to get to the ingredients inside the hard gelatin capsules. إذن, what I mean to say that mainly in the capsule shells you have gelatin and water, sugar, color, opaquant agent, and preservatives, okay, and sometimes lubricants are all considered as additional ingredients in the composition. The main thing is gelatin and water. Okay. طبعا if you look at this figure, you will see here the body of a capsule shell that is transparent. معناته مش ضايفين لا color, no color, وما في عندنا ايش opaquant agent. On the other hand, look at the cap here. We have color, which is green color, but we don't have opaquant agent because light can pass through. Look at this body and this cap. We have color, but also we have opaquant agent, اللي هو titanium dioxide, that prevents the light to pass through the shell. So normally capsule shells are colored, and in some cases the color of the cap is different from the color of the body, as you see in this figure. You have here green color while you have here transparent shell. So the question is, why do we need, or what is the importance of coloring if we need to add a coloring agent and opaquant agent? The important is it allows us to differentiate between different commercial products. Yani, for example, sometimes when you talk to your friend, you'll say, oh, the blue capsules, or oh, the green capsules, or the brown capsules. This will allow you to differentiate between commercial products. Yani, when you have products, capsule products with different colors, it can allow you to differentiate between them. Also, because you will be able to hide the drug inside. So if the drug has an unacceptable color or a color that is not attractive to the patient, you can hide it inside the capsule shells. Okay, what we need to talk about now is, where do you get gelatin from? Okay, and how do you make the capsule shells? So you need to have an idea. Now, gelatin itself is not a natural material, but it is derived from a natural source. Okay? So how do you get gelatin? You can get it from hydrolysis of collagen. Hydrolysis, what does it mean? It means waterlysis. Yani, let's say the change in the compound because of water, the presence of water. Now this can be in acidic condition or basic condition, can happen. And collagen comes from connective tissues. It's the main ingredient or main protein for connective tissues. For example, your ears contain collagen. Okay. So from collagen you need to hydrolyze collagen in order to get gelatin. Where do you get this collagen from? You get it from animal skins and bones. So these are the raw material used to make gelatin. Now we have two types of gelatin. One, we call it type A. Okay, and type A is produced by hydrolysis of collagen that comes from the skin. And we have type B. طبعا A شوفوا هون A acid, B base. طيب, so type A is produced by acid hydrolysis, type B is produced by basic hydrolysis. The acid hydrolysis, as I said, happens mainly from animal skin. Yani you are using animal skin and you are putting it in acid, and you will soak it for 7 to 8 days for the connective tissue, for collagen to convert to gelatin. On the other hand, type B gelatin takes longer time because it needs pre-treatment. Yani you need to do certain things before you can use the bones. First, طبعا takes longer time, as I said, 10 times as long as the type A gelatin, which this is from the skin and this is from the bones. طيب, how do you do it? You take the bones and then you need to decalcify the bones, يعني remove the calcium from the bones. This happens by soaking the bones in acid. يعني first you need to do pre-treatment. First put the bones in acid, مثلا phosphoric acid, etc. Leave it for some time. The bones will become spongy-like material. Spongy يعني sphingy. Okay? يعني soft. Now this spongy material is called osine. Osine اللي هو the same as collagen. Okay? So the result of decalcification or removing calcium is you get spongy material called osine or collagen. طيب, what do you do now as a byproduct? Okay, byproduct يعني product جانبي. Okay, it's not the one that you are aiming at to get gelatin. Byproduct من decalcification هاي that you did, removing the calcium, is producing calcium phosphate. Now calcium phosphate can be used also in formulation to be filled inside the hard gelatin capsules. It can be also used in making tablets, so it has uses. It's not we throw it away. So we can use calcium phosphate, which is a byproduct from the process of removing calcium from the bones. Now the osine that we want to use for gelatin is then soaked in lime. Lime اللي هو basic hydrolysis, and it takes long time. It can take 2 to 3 months for this process. So we put it in lime. Lime المقصود فيه مش الليمون. Lime is to refer to as calcium hydroxide, which is a base material, calcium hydroxide. So we leave it there for several weeks to produce gelatin B. طبعا في differences بين gelatin A و B. I will not talk a lot about these differences, but the main thing for you to know is that capsule shells are made from mixture of gelatin A and B. فإذا the gelatin that we use for making capsule shells are actually mixture of gelatin A and B. Gelatin A that comes from the skin, from the pork skin, انتبهوا, I'm talking about pork, is to give flexibility to the or plasticity or flexibility to the capsule shells, while gelatin that comes from the bones are to give firmness to the capsule shells. يعني يعطيها الصلابة, becomes stiffer. Okay, so we need both of them to be in the capsule shells. طيب, how capsule shells are made? Okay, and now what I talked about was how to produce gelatin, right? Now I need to know how to produce the capsule shells. طبعا the process is referred to as mechanical dipping of pins or pegs. Okay, إذا شو اسم البروسيس by which we produce the capsule shells? اللي هي الميكانيكال dipping of pins or pegs. طب خلونا, in order for me to explain it to you, I will go to the following figure. Okay, طلعوا, this figure is very important. طيب, what happens? This is what you see here, okay, is a pen or peg. يعني زي الأصبع, like a finger-like projection. Here you have the plate holding many of the pins or pegs. What you have here, okay, what you see here, okay, is a reservoir or a container or a vessel containing gelatin, water, gelatin water, because they are the main ايش حكينا constituent of the shell, hard gelatin capsule shells. They contain gelatin water, and of course you may add, as I said, color, opacuant agent, preservative. Okay, so this is in this reservoir. طبعا gelatin solid, but when you put it in the reservoir and you heat it, for example, let's say to 50 degrees, it becomes like viscous melted material here. Okay, now these pins will be dipped يعني يتغمس جوا, يعني immersed. مش حكينا mechanical dipping, هي dipping. So the pen is dipped inside the melted material. البنز هاي بتكون colder than the temperature of the reservoir here. What will happen? The gelatin or the melted gelatin will solidify around ايش الpen, يصير له solidification. إذا في عندنا first dipping, it will solidify around the pen, but especially I'm talking about the outer surface, it might still be a little fluid, يعني it might have drops coming out from the pen. That's why you need to do spinning يعني rotation. You need to rotate in different direction the pens so that the melted gelatin spreads evenly around the pen. Okay, after that, after spinning, you will do a drying process. So you will dry it in a controlled temperature and controlled humidity. So you will dry it. After drying, you will do stripping or removing. So you will have, or the machine will remove these bodies or caps, will remove it from the pins or pegs. إذن هذا الpin أو الpeg, now this needs to be removed. Okay, we call stripping or removing. After this gets removed by the machine from the pin or peg, it gets trimmed يعني cut. فعندنا cutting, trimming to the correct size. طيب شو correct size? It depends. Am I talking about body or cap? Okay, because for body and cap you will have different peg diameter. Okay, the diameter تاع الpeg is different. Which one is larger, the diameter for body or for the cap? Which one is larger diameter? طبعا remember I told you that the diameter of the cap is larger than the diameter of the body, and that's why the cap slides over the body of the capsule. طيب فإذا it will be cut or trimmed to the appropriate size. Then the capsule will join, because they will not be separate, they will be together, but in a pre-closed position, or we call it also pre-locked position. Okay, then it will be packed and stored in the right environment. بعدين تيجي the Gelfar or other pharmaceutical company will buy these capsule shells in order to fill them with the required formulation. طيب, here when I say pre-locked or pre-closed position, we have closed position and we have pre-closed position. Pre-closed position will allow the cap and the body to detach easily. يعني I can open them easily. But if I put them in a closed position, what will happen? It will be difficult to detach the body from the cap and it might break. Because they are not already filled. يعني the body of the capsule is not already filled. That's why I need to keep it in pre-closed position. Only after filling the capsule shell, after filling it with formulation, only then I can put it, or I must put it in closed position in order to package it and then taken by the patient. Okay? فإذا the question is, what are the steps in the production of hard gelatin capsule shells? Number 1, dipping. Number 2, spinning. Number 3, drying. Number 4, stripping. Number 5, cutting or trimming. Number 6, joining in a pre-closed position. But what is the method of producing hard gelatin capsule shells? It's called mechanical dipping of pins or pegs. Okay? The capsule shells are produced. Remember this figure. I have a video for that. I will go back to capsules. Capsules. And then capsule shells production. Let's say how. Okay, what you see here. See what you see here. The plate containing pegs or pins. And what you see beneath this, down here, you see colored melted gelatin with water. So these pins or pegs will dip inside and they will be coated with the melted gelatin. Okay, watch this. So you see here the dipped pins or pegs inside the melted gelatin that contains this color. Okay, so what did you see happening here? After dipping, the next step is spinning. So you see these pins in the plates that you see here. These pins or pegs, they spin, they rotate forth and back in order to make sure that the coating around the pins are uniform and the thickness of the coating is sufficient enough. Okay? I want you to notice that in this machine it makes body and caps. Now one of them white color, the other one is reddish color. So what I mean to say is that the pins that are for caps are dipped in different reservoir that may contain different color than the pins for the bodies. Of course, the diameter of the pins and pegs or pegs will be different whether it is for body or the cap. For the cap it will have ايش حكينا, it will have wider diameter لأنه cap will slide over, not inside but over the body. Okay, طيب after spinning, do you remember what is the next step after spinning? Drying. Okay, let's see this step. Okay, now of course after drying there will be the removing or stripping and then trimming or cutting to the appropriate size and then joining in a pre-locked position. Look at this photo. You see the pen or peg which is already taken out from the melted gelatin preparation. Please notice here how it's dripping. شايفين the dripping? That's why we cannot leave it like that. We need to spin these pens or pegs in order for the melted gelatin to spread evenly around the pen or peg. Okay, let's go back. Actually, what I said is summarizing all what you see here. Okay. طيب, question. Can I طبعا all of you know how hard gelatin capsule shell look like. It looks like this, and it has not really changed since maybe 160 years. It's the same shape, but it is possible that I can change little bit in the capsule shell. But how can I change the shape of the capsule shell? All depends on what? Do you know? All depends on the shape of pens or pegs. لأنه shell, capsule shell, will take the shape of pens or pegs. If I change the shape of pens or pegs, then I will end up with maybe little different shape. For example, look at this product of the company Eli Lilly. You will see that the body part, the bottom of the body part is more tapered. Okay. طيب, look also at this product. You will see that the body and the cap are tapered from the top. It's not like smooth curve. It's more tapered. Okay. فإذا I'm able to produce distinctly looking capsules by using the appropriate pins or pegs. Okay. طيب, I want you to look at the figure here, the one that you see here. Okay, this is from Capsule Gel. Capsule Gel is one of the very famous companies in producing capsule shells. Look here. This is the Conisnap design. Look at the body. This is the body and this is the cap. In the body, I want you to notice the following. See this part. It's little curved. اللي هو one. It's curved. It's not like straight. It's little curved. Okay. And then look at number 3. 3 is في عنا depression هون. Okay. Depression. Depression يعني انخفاض. Okay. Look at the cap. This is the cap. في عنا deep depression هون. Deep depression. وفي عنا اللي هو number 2. هذا deep depression. وفي عنا number 2 اللي هو small depression. When you want to put it in a pre-closed position اللي هو after producing the shells, then the cap must slide over the body and 2 اللي هو small depression must snog 3. Because it's small depression, it can be opened easily. But after filling the formulation, this cap, which you have detached to fill the formulation, and you have to open this in order to fill the body, this cap needs to be pushed down so that the depression 3, اللي هو هذا depression, fits into the depression 3 of the body. يعني depression 3 of the cap fits into the depression 3 of the body, and this will make it very difficult for one to open the capsule and remove the content. طيب, another design اللي هو كوني سناب سوبرو. What you will see here, what you see here is that actually the cap, this is special design, the cap is almost the same size as the body. Okay, شايفينه البادي والكاب almost the same. شوفوا الكاب is reaching to the point where the curve starts to form. طيب, what is the use of that? The use of that is to make it difficult for someone to detach body from the cap. يعني after closing the Koni Snap Sopro, after putting it in closed position, it will be difficult to remove the cap. Why? How are you going to hold it? You will hold this one and this one, right? But this one is difficult to hold because it is curved. So you will not be able to hold this one because it is curved, so you will not be able to detach cap from body. طيب, notice here again, see the edge is curved. يعني الطرف number 1 is curved. Also, as I said, number 1 here is curved. It's not straight. And it's not coming straight. It's a little bit curved. This is to prevent something called telescoping. What do we call it? Telescoping. Read this one. Telescoping. The tapered rim that is here is tapered in order to prevent telescoping. Telescoping, what does it mean? When you want to fit the cap with the body, it is very possible, because of the flexibility of the body and the cap, that the cap and body will touch each other at the rim, and they will press on each other, causing what we call telescoping, and this can cause damage for the capsule shells. Okay. طيب, we need to know the properties of the gelatin capsules. Gelatin capsules can dissolve readily at body temperature. يعني when you swallow it, when you swallow the capsule filled with the formulation, it will dissolve readily at the temperature of the body, which is 37 degrees. If the temperature, طبعا, this is in vitro, let's say, if the temperature is less than 30, then it will not dissolve, but instead it will swell and distort. Swell يعني ايش؟ بنتفخ. Distort يعني it will not retain its shape, بصير مطعوج يعني. Okay? So at body temperature we have no problem. A new type of capsule shells. طبعا what we talked about اللي هو gelatin capsules. في عنا new type of capsule shells. Hard capsule shells that have been produced in the past 30 to 40 years, but still have not gained full popularity in commercial products. It's used but not very common. اللي هو we call it vegetable capsules or vegetable capsule shells. Previously we said that we make gelatin capsule shells from, or we get gelatin from what? From the skin and the bones of animal. Sometimes we may use the bones of bovine, اللي هو البقر. But in any way, we are using it from animal and usually pork. And because of sensitivity regarding using animal, which may be not slaughtered according to Islamic way, or maybe some people, they are vegetarian, so they don't like to have something with animal source. In this case there is alternative اللي هي vegetable capsule shells. Vegetable capsule shells are taken, or the main constituent of these shells are HPMC. HPMC طبعا in addition there is a little amount of water. HPMC stands for hydroxypropyl methyl cellulose. Hydroxypropyl methyl cellulose. طبعا it's cellulose derivative. Now the good thing about these shells, they can dissolve at temperature as low as 10 degrees Celsius. Actually it dissolves better in cold water than in hot water. So these capsules are available, and one can use them for encapsulating drug products. Okay, but as I said, gelatin capsules are more popular because, who knows why? Because it has been there in the market for very, very long time. And there is another reason. Gelatin shells dissolves faster than vegetable capsule shells. وبالتالي gelatin capsule shells will release the drug in a faster way. You need to know that the most famous two companies in the whole world are Qualicaps and Capsugel. Okay, في عندنا Capsugel, we have also Qualicaps. These are very famous companies with over 100 years of experience in making capsule shells. Okay. طيب, how do you store the capsule shells or capsule preparations? As I said, it's very important to control the humidity. The optimum humidity is between 35 to 45% of relative humidity. Temperature should not exceed 25. Like, what happens if the humidity, let's say 60? What will happen to the capsule shells? Capsule shells will absorb moisture from humidity and become sticky, and also will be liable to contamination by bacteria. What happens if the humidity is very low, let's say 20% relative humidity? Then in this case it will lose water from the shell. وبنعرف إنه الwater is very important in the capsule shells. ليش? To give the capsule shells flexibility. So when it loses water, it becomes fragile and it will break easily, and it will not be able to withstand the stress that comes from the machine and from handling the capsules. So you need to be aware of this storage condition. Now, capsule sizes. So do we have different sizes for capsules? Yes. For human use we have 8 sizes. Why I said that for human use we have 8 sizes? Because we have also capsules for animals that can be larger than the sizes we have for human. Now, these are the 8 sizes, and we give them numbers. These numbers are 000, which is the biggest, then 000, 00, 0, 1, 2, 3, 4, 5. Then it's not difficult, okay? So the biggest is 000, and the smallest is 5. This is the smallest, okay? طيب, for human use we have 8 sizes, but commonly they use the sizes from 0 to 4, and these are more common. شوفوا, 0, 1, 2, 3, 4. But what about 5? Well, 5 is very small, so the drug must be really in very small quantity to put it here. What about 00 and 000? It's a little bit large, and a human can have difficulty, or let's say the patient can have difficulty swallowing these big capsules. Okay. طيب, because sometimes we need to use big capsules and this can cause problem, that's why we have new types of capsule sizes. Okay. في عندنا what we call elongated sizes. شو بنحكي لهم؟ elongated sizes. طب what we need, why we are, or why the companies are producing a new type of capsule? مثلا, this is 0. Okay. elongated capsule will be referred to as 0EL. EL يعني elongated. Okay. 0 elongated. Because the companies do not want to use very big capsules, they said, okay, we'll keep the same size, but we'll make it, yani same diameter, but we'll make it little longer. Okay? So you have a homework. This homework is to tell me what is elongated capsule sizes. طبعا معظم elongated capsule sizes are 0 and 1 and 2. They are for these capsules. 0, 1 and 2. طيب, so what are these elongated? طبعا they are in order to accommodate more formulation. يعني بدل ما اروح على, for example, instead of 0 I need to use 00 because there is ايش, there is more space here and there is less space here. So instead of doing that, and it will be difficult to swallow it, we will use the same capsule but the elongated type. It's little longer. But I will, this is a homework. I will upload the source اللي هو من Pharmaceutics, the Science of Dosage Form Design. I will show you the homework. Okay, this is what Alton's Pharmaceutics. You will see the answer here. Okay, it's already highlighted to you. Okay, so I said that 000 is the one with largest volume inside. طبعا when I say the volume here, I'm talking about the volume of the body, not the whole volume. Why I'm talking about the volume of the body? Because when you want to fill the capsule with formulation, you are only filling the body. Okay. So if you see the capsule size 000 can accommodate a volume of 1.4 ml. 00 اللي هو 0.95 ml. 0 اللي هو 0.68 ml. So you will see that as you go up in numbers, the volume that can be accommodated becomes smaller and smaller. Okay, the part that I'd like to talk about now is, okay, I have the capsule shells. Now I want to fill them with the formulation. So what size do I need to use? And what is the formulation that I need to fill inside the capsule shells? إذن, what I will be talking in this part of the video today اللي هي developing and preparing the formulation and selecting the capsule size. This is what I will talk about now. Later in the video I will talk about filling the capsule shells, capsule sealing, cleaning and polishing. I will talk about these things. طيب, let's say I have a formulation and I need to fill this formulation in a capsule. Now I have to determine what size do I need to buy. مش حكينا the two famous companies are Capsugel and Qualicaps. So when I contact them, what size do I need to tell them to send me? Do I need to tell them to send me, for example, size 0 or size 0 elongated or 1, 2, 3? Which size? طبعا the rule is use the smallest size of capsule that can fit your formulation. Why you need to use the smallest size? Because it will make swallowing easier. but at the same time this shell or this capsule shell size should fit your formulation. So how do I determine ايش الكبسول size? طبعا there are different methods. I will talk about few of them, how to select the right size. First, you need to know your density of the powder. We call it bulk density. Now I want you to remember powders and granule topic. Okay, powders and granules topic. I talked about bulk volume and bulk density. Now what is the density or the bulk density? Take your formulation, okay, put it in a measuring cylinder. Yani for example, weigh 50 gram of your formulation that contains the drug and other excipients. Okay, fill them in measuring cylinder, tap the measuring cylinder, tap it, yani knock the measuring cylinder so that the volume gets reduced to the to the smallest volume you are able to do. And then calculate the bulk density. شو bulk density? If you remember, what is bulk density? Okay, the density of the bulk. Okay, خلينا نحكي هون B, sorry. Bulk density is equal to the weight of the powder على the volume occupied, right? فإذا this bulk density, calculate that bulk density. It will tell you what weight will occupy what volume, right? طيب. Suppose you need to fill, okay? Suppose you need to fill, let's say, half a gram of the formulation, okay, half a gram of your formulation in each capsule. طيب. And when you did this experiment, اللي هو to get the bulk density, you found that, let's say, the bulk density is 0.5 gram per ml. How did you get this bulk density? As I said, you took 50 gram, you put it in a measuring cylinder, you tap, at the end, the 50 gram occupied, let's say, 100 ml. ف 50 على 100, 50 gram divided by 100 ml بيطلع لنا ايش؟ 0.5 gram per ml, which means شو معناها؟ Each 0.5 gram from the formulation will occupy a volume of ايش؟ 1 ml. Each 0.5 gram will occupy 1 ml. معناته what is the volume of the capsule I should use? إذن it should be minimum 1 ml لأني بدي أضيف نص جرام, right? the half a gram will occupy 1 ml. إذن the capsule choice will be إيش? To see which one from here will take 1 ml at least. طبعا I cannot use this because this is 0.95 ml. معناته I cannot put all the 0.5 gram inside here, but I can put it here, right? طيب, this is the way you should think. طيب, there is another example as you see it in your textbook. Here we need to fill in the formulation or in the capsule from the formulation we need to fill 350 انتبهوا milligram. So I need to put this formulation inside the capsule. The bulk density is 0.7 gram per ml. How or what size do I need to use? طيب. طبعا I can do it in the same way here. For example, this is 0.75
per ml. This means ايش؟ انه every 0.7 gram of the formulation what will take 1 ml. Okay. طيب how much I need to use? I need to use 350 milligram. Now watch here, this is gram, this is milligram. I need to convert the milligram to gram. So what do I say? What do I do? Okay. بحكي each 1 gram is equivalent to 1000 milligram. So if I have 350 milligram, that will be how many gram? It will be طبعا divided by 1000, then you will get 0.35 or 0.350 gram. Okay. طيب فإذا now I will change this one to 0.350 or 0.35 gram. So here I will say okay, 0.75 gram takes 1 ml, 0.35 gram will take how many ml? So in order to get this one, what do? You multiply this اللي هو 0.35 by 1, then divide it by 0.75. فشو بطلع الجواب؟ اوكي 0.35 مضروبة بواحد, then divided by 0.75 equal to 0.4666 ml. إذن the answer is 0.4666, so I'll make it 0.47 ml. Okay. طيب 0.47 ml. إذن this formulation that I want to fill will take a volume of 0.47. إذن which capsule size do I use? Go back here. Where is 0.47? Can capsule size number 2 accommodate 0.47? No, it will not be enough. What about capsule number 1, 0.5? Yes, I can put 0.47 here of the formulation. What about this? Yes, I can put. What about this? Yes, I can put it inside. What about this? Yes, I can put it. But which one I will use? I will use the smallest one possible. Why? Because it will be easier to swallow 1 than 0 or 00 or 000. You got it? طيب, the other way is just, if you want to just memorize, the other way to do it is divide the weight of the formulation divided by the bulk density. This is directly. فشو بصير عندنا؟ بصير عندنا 0.35 اللي هو weight of the formulation that I need to fill divided by 0.75, and then you will get the answer اللي هو 0.47 ml direct. Okay. طيب, this is one way. The other way to do it اللي هي take all your formulation. For example, let's say in my formulation I want to fill 200 capsules. Okay. إذن I prepare the formulation of drug and excipients. I want to fill them inside 200 capsules. So what do I do? طيب, the way is not difficult. Take your formulation, put them in measuring cylinder. Okay. So all your formulation that you want to fill inside the capsules, put them in a measuring cylinder. So you have here measuring cylinder, and then find out what is the total volume of your formulation. So your formulation is here. Okay, this is your formulation in the measuring cylinder. So what is the volume of that formulation? Let's say it is 40 ml. Okay, isn't the formulation that you want to fill in the 200 capsules اللي هي 40 ml. طيب, then what do? Take the volume of the whole formulation اللي هو 40 ml and divide it by the number of capsule you want to fill بيطلع عنا ايش let's say 40 divided by okay 0 goes with 0 بصير 4 على 20 is 1 by 5 1 by 5 يعني بصير عندنا 0.2 ايش ml. طيب اذا each capsule will be filled with a volume of 0.2 ml. بروح باجي هون شوفوا can I use this one? No. Can I use number 4? Yes, I can. Because I need 0.2. This is 0.21. So I will use number 4. So actually there are more than one way to deal with this. I mean to choosing the capsule size. There are more than one way. It's not just one way. I just described to you two ways so far. Okay. So now we selected the size. Now what about the ingredients used in the capsule formulation? Here what I mean is what I need to add في formulation in addition of course to the drug. طبعا the drug is there. What else do I need to add? طيب. Number 1 we have the diluent or fillers. Is a number 1 diluent or filler. Number 2 category of material اللي هو ايش lubricant and glidants. Number 3 اللي هو disintegrating agent. إذا في عندنا 3 categories of materials that I may need to add to the ايش to the capsule formulations. طيب let's talk about each one of them and why they are added. What is their function? Diluents. Why we are adding diluents? We are adding diluents mainly okay for خاصة في industry, not in a small scale في industry, mainly to form plug plug forming. This is one. I will talk about it. Number 2 is to increase the quantity. Okay, this is number 2 why we are adding diluents. Number 3, because diluents are usually added in a larger quantity or largest quantities compared to the drug and other excipients, and because they are free flowing, they will improve the flowability of the formulation. إذا هم مش they are added to improve the flow, but usually because they have free flowing property, that's why they will improve the flowability of the formulation. That's good. Okay, but mainly they are used for plug forming, and that is mainly in industry, because the way the material is filled is first by forming plug. هلا what is a plug? Plug is like something cylindrical. I will draw it for you. Okay, something cylindrical like this. This is a plug. يعني compressed material. يعني when you mix the diluent and the disintegrating agents and the lubricant, you need to compress the powder slightly, little bit, not like tablets. Okay, if you remember, when we talked about the advantages of capsules, we said that they are filled with uncompressed material. طب البلاج معناته صار في عندي compression, so I have compression here. This is opposite to what I explained previously. No, it's not the opposite, because the plug here can break very easily. It's not like tablets. Some of them break when they get inside the capsule. They will break. They are very light compression, not like in tablet. In tablet, remember, and we will discuss this later, the compression is very high. Okay, يعني very high compared to the plugs formed when we want to fill the capsules. طيب, increasing the quantity. If the drug quantity is small, then in order to deal with the small quantity of drug, because it will be difficult for machine to deal with the small quantities of drug, then I need to increase the quantity of the formulation. free flowing, I already described that. So this is the reason why we are using diluents. Diluents can be classified to organic diluents and inorganic diluents. So we need to know what are the examples of each category of diluents. Organic diluents include anhydrous lactose, starch, hydrolyzed starch, and avisal. Now this is a different. This is not like the others. The others are the generic name for them, but avisal is a trade name. Avisal, because it's very famous, okay, it's very famous trade name. That's why I'm putting it here along with the other generic name. Now what is avisal? Avisal is microcrystalline cellulose. It's very famous excipient. It's very famous as a diluent and even as because it comes in different grades, and avisal comes in different grades. Some of them also, they are good disintegrant. So avisal, what is avisal? It's a trade name for microcrystalline cellulose. So the famous thing about the avisal that it allows the formulation to be compressed easily. So with little pressure I can get this plug. Because otherwise if the formulation is non-cohesive, يعني ما بيلزقوا في بعض, and I do little compression, what will happen to them? They will not form a plug, but they will return back to their powder form. So how to make this powder form? To make it as a plug in this case, it's non-cohesive. So if I compress it, it will not form plug because they will not stick to each other. So the way to do that is to add avisal in the formulation. So with little compression you will have the plug. The inorganic diluents اللي هو if you remember when I was talking about gelatin production from bones, and then I said that bones need to be decalcified, يعني remove calcium, we said that the byproduct is calcium phosphate. Now this is what I'm talking about, اللي هو dibasic calcium phosphate, also called dicalcium phosphate, and also called calcium monohydrogen phosphate. Now this one is the main inorganic diluent that is available. One of the trade names for this product is M-compress. M-compress, okay? It can be used in the excipients or for the formulation of drug to be filled inside gelatin capsules. طيب, so far you studied different types of diluents. So which diluent do I use with my drug? Well, generally it says the following. If your drug is poorly soluble, يعني its solubility is very poor, then it's better to use soluble diluent with it. Okay, so if your drug is poorly soluble and you want to use a diluent, عشان in the end you want to put it inside the gelatin capsule shells. So in this case it's better to use soluble diluents. زي ايش عندنا soluble diluents? We have lactose, sucrose, mannitol, sorbitol. But what is the reason? They say that according طبعا to studies, if your drug is poorly soluble and your diluent is not soluble, in this case it will be difficult for the water or the gastric juices to get inside the plug. Let's go back to the plug. To get for the water to get inside and dissolve your drug. But if your diluent is soluble, this will allow the juice, gastric juice, to get inside and reach the drug. طيب, if the opposite, let's say your drug is soluble in water, so in this case use insoluble diluents or fillers. okay, like starch, cellulose, microcrystalline cellulose, calcium phosphate. Now, they will wet. These materials can wet. There is no problem with wetting. The problem is with dissolving. So in this case, why we need to have insoluble filler in this case? If the filler is soluble, then it will compete with the drug اللي هو soluble drug. The drug is soluble and the filler is soluble. So both of them will start competing for water molecules to dissolve. يعني both want to dissolve in water. Both of them, طبعا تعرفوا انتم, maybe you took it in physical pharmacy 1. So the drug will be surrounded by the solvent molecule. يعني drug molecule surrounded by solvent molecule. إذا في عندنا diluent, the diluent will start competing with the drug for these molecules. Okay? يصير عندنا الاكسبيانت أو diluent molecule also wants water molecule to surround it. فبصير competition. That's why it's better ايش حكينا to use in this case insoluble filler with soluble drug and soluble filler with insoluble drug. طب the second category اللي هو the use of lubricants and glidants. Now remember, and you will see this later, that we have to be careful about the terms. Okay? And I will explain a little bit about lubricants and glidants because I wanted to be careful. Okay, in the beginning, let me show you the whole. I can classify lubricants to 3 classes. 1, glidants. 2, lubricants. 3, anti-adherent. طيب, so lubricants are classified to glidants, and lubricant glidants, lubricants anti-adherent. We will talk about them more in details later, but glidants are meant to improve flow of the formulation. كلهم flow activator كمان. Lubricants are to prevent the sticking of the formulation to the machine. طبعا anti-adherent we will talk about it later في التابلت. Okay? But these are important when we want to fill the formulation inside the capsules. The formulation needs to be good flowing and it should not stick to the machine parts. That's why we need glidants and we need lubricants. Now, do you know what is lubricants? Be careful with the term, because lubricants can be classified to lubricants, glidants, lubricants anti-adherent. But when I say glidants and lubricant, I mean these 2 classes. Okay? طيب, طبعا we need good flow, because if we don't have good flow, we will have weight variation. Weight variation يعني what enters the capsule shells بالformulation that I'm trying to fill can have different weights. يعني one capsule will have low filled formulation, another capsule will have high filled formulation. فعندنا weight variation. One of the very famous glidants, okay, اللي هو silicon dioxide. Silicon dioxide is one of the most powerful glidants. It's one of the most powerful glidants and is available as trade names اللي هو كابوسيل and another trade name اللي هو ايروزيل. اذا في عندنا two trade names here, كابوسيل, ايروزيل. Remember, this is silicon dioxide. We talked about previously titanium dioxide. Titanium dioxide is different. Titanium dioxide is opaquant agent مستخدم في الكبسول shell to make it opaque. Okay. طيب, you need such glidance especially if you are using Avicil اللي هو microcrystalline cellulose or lactose. But if you are using a diluent such as starch, in this case, you may not need to have glidant or lubricant, because starch already has property of not only diluent, but also it has gliding and lubricating properties. In this case, you may not need to use glidant or lubricant, or if you need to use them, then they will be with small concentration. اللوبريكانت حكينا على flow activator or the material that improves flow. Now we want to talk about lubricant to prevent the sticking of the material to the machine parts while filling, while transferring. Now, one of the most famous lubricant they use especially in tablets اللي هو magnesium stearate. The problem with magnesium stearate lubricant, ايش هو البروبلم؟ انه it's very hygroscopic in nature, يعني دهني. So it's very difficult to wet the plug. Let's go to the plug. Where is the plug? Okay, this is the plug. So when you adding lubricant and you want to form the plug will be surrounded by lubricant here. Okay, so the lubricant will be here and it is surrounding the plug. So it will be difficult for the water or the gastric juice to get through this very hydrophobic material. Okay, this is the problem with magnesium stearate. Think of it like the frying pan تيفال. تعرفوا تيفال, frying pan. The material coating the frying pan اللي هو التeflon is hydrophobic in nature, and that's why, for example, when you want to fry eggs or something else, it doesn't stick. Okay, now this is the same thing here. When you are adding in the formulation lubricant, this is the formulation, you are adding lubricant and then you compress it, the lubricant will travel to the surrounding and forming a hydrophobic layer, and this is a problem. So what is the solution for that? One is to use the minimum amount of magnesium stearate so that this hydrophobic layer is not thick. Number two, and I think you are studying this in physical pharmacy, is to use a surface active agent such as sodium lauryl sulfate, because you know that these surface active agent will help in wetting the plug, even though you have magnesium stearate. The third option is to replace magnesium stearate with a hydrophilic lubricant. This has been developed recently to substitute magnesium stearate in tablet in capsule formulations. These are hydrophilic and they do not have the same problem as magnesium stearate. The third category, and this is the last one, which I will end my video today, part 1, اللي هو using disintegrating agent. First, what is the function of disintegrating agent? Why we need to use disintegrating agent? Go back to the plug. This is the plug. So in the formulation, I want to have disintegrating agent. What is the function of disintegrating agent? As I said, in industry, they rely on forming plugs. Now for this, the plug to break easily when it gets to the stomach, you need a disintegrating agent that is capable of breaking the plug easily in case it is not broken because it's compressed lightly. So when it goes to the gastric juice, you need it to break easily. The job of the disintegrating agent is to fragment or break the plug to parts. Now, in the old times, before maybe 30 years or more, disintegrating agents were not used in the plug formulation. ما كان يحطوا disintegrating agent. They used to put it only في التابلت formulation. في التابلت. So in the tablet formulation you have a disintegrating agent. شو وظيفته? What is the function? Is to break the tablet to parts. Why? In order to improve dissolution. Because when you break the tablets, the surface area increases. Increasing the surface area will improve dissolution. But why in the past they used not to put it in the capsule formulation? What is the reason for that? Now we will talk about that. Remember that tablets are compressed at much higher pressure compared to the plug. فبالتالي, therefore, the pores inside the tablet are much less than the pores in the plug. طيب, how does the disintegrating agent work? It can work mainly, not only, but mainly by one of the two ways. شو هم one of the two ways? Either by what we call swelling action. Swelling action شو يعني? Swell ينتفخ. Okay? It absorbs water or gastric juice and becomes bigger. This is one way. The second way is by wicking action. Wicking يعني زي يشرب. Like when you put the sponge in water, the sponge takes water. So it's wicking. So either by swelling or by wicking. Swelling, as I said, cause the disintegrating agent الموجود هون to swell. فبصير ايش? Bigger. So it's inside the tablet, it absorbs water and becomes bigger. When it becomes bigger, the tablet is compressed, ايش حكينا? Higher pressure than plugs. طيب, what does it mean? The pores are smaller and the spaces are less in the tablet. So with little swelling, it will break the tablet. Then little swelling will cause the tablet break because there is no space inside the tablet to take the swelling, to accommodate the swelling of the disintegrating agent. فإت will break. Wicking شو بصير? It will dissolve in water, creating channels inside the tablet, causing it to ايش? To break. طيب, why it's not working in the plug? The reason is there are a lot of spaces, so swelling or wicking will not make a big difference to what happens in the plug because it's already there are a lot of voids and spaces inside. But in recent times, they synthesized a new material that is capable of swelling many times the normal swelling of normal disintegrant or wicking to a greater extent than the normal disintegrating agent. Okay? يعني طلعوا material. Now we have a new synthesized material that is more powerful than the normal disintegrating agent. So they said, okay, this material can now work في الplug, even في الplug في spaces, because these material are very powerful, they will be able to break the plug. طيب, so now in capsule formulation I cannot use the normal disintegrating agent, I need to use this special, very powerful, strong disintegrating agent. Because they are special and they are powerful, they call them super disintegrants. Super, زي Superman, Superwoman. So these are super disintegrants, not just any disintegrants. How do they work? By swelling or wicking, but their action is more powerful than the normal disintegrating agent. So let's go back to the disintegrating agent. طيب. Of course, I can add surfactant, but surfactants are to enhance wetting and therefore dissolution. Disintegrating agent is to help in the breaking up of plugs. So I have super disintegrants. I said, for example, can use the action of swelling. Examples mean super disintegrants that act by swelling action, okay, is sodium starch glycolate and cross carmelose. And you need to memorize this. Example of super disintegrants that swell اللي هو sodium starch glycolate and cross carmelose. And example of those super disintegrants that wicks are or is cross povidone. Now pay attention to cross carmelose and cross povidone. Cross carmelose means what? Actually, it's a short for cross-linked carboxy methyl cellulose. احفظوا cross-linked carboxy methyl cellulose. وكروس بوفيدون احفظوها cross-linked polyvinyl pyrrolidone. Cross-linked polyvinyl pyrrolidone. Okay, so these are the ones that are suitable in capsule formulation. So again, I said that the formulation contains, in addition to the drug, it contains excipients. These excipients include diluents, lubricants and glidants, with third category ايش؟ disintegrating agent. Should disintegrating agent, it has to be ايش؟ حكينا Superman, super disintegrants. طيب, after filling the capsules, let's say I filled the capsules and I need to do enteric coating. نتذكر شو الانتريك coating؟ we said, or we brought this up before when we were talking about the advantages of capsules, that we can control the drug release rate or the release of the drug at certain sites. فحكينا we use enteric coating. This enteric coating is supposed to do what? It's supposed to protect the shell in the gastric juice in the stomach, but allow the shell to dissolve in the intestine when the pH rises. طيب, if we want to do it, then after filling the capsule shells with the formulation and closing the capsule, we can immerse or dip. We can dip the formulation. Oh, sorry, not the formulation. We can dip the filled capsules and closed capsules. We can dip it in either ethanol or even aqueous solution containing what? Containing the enteric coating. شو الانتريك coating? These are polymers. يعني polymers dissolved in alcohol or dissolved in water. طيب, these solutions that contain cellulose acetate phthalate as a polymer or polyvinyl acetate phthalate اللي هم CAB و PVAP. CAB يعني cellulose acetate phthalate و PVAP اللي هو polyvinyl acetate phthalate. Now these enteric polymers are dissolved in either aqueous or alcoholic solution, and then you dip the capsules inside them, then remove them. The liquid will evaporate, leaving a coating of the enteric coat around the capsule. طيب, what is the property of this enteric coat? Because the polymer that I'm talking about here, هذا البوليمر, which is a CAP or PVAP, we have other polymers as well. Because the polymer is acidic in nature, فwhen the capsule is ingested and it's in the stomach, it's acidic, right? So the stomach is acidic, so there is no interaction between the gastric juice and the polymer, so the polymer will not dissolve. But when it goes to the intestine, the pH is higher now. Now there will be interaction between the gastric juice and the polymer will dissolve in this case. When it dissolves, it will expose the capsule shells to the intestinal juices or enzymes, and you will have the disintegration of the capsule shells, releasing the formulation inside. By this, we have actually completed part 1 of capsules. I hope you enjoyed my explanation.